Welcome back to Advanced Geometry with Mrs. RRubright. Today's lesson is 10.3, Apply Properties of Chords. In the diagram, circle P is congruent to circle Q. Segment segment FG is congruent to segment JK. And the measure of arc JK is 80 degrees. Find the measure of arc FG. For some reason this formatted weird. That arc symbol should be above the FG. Okay, so what is the measure of arc FG if JK is 80? These two chords are congruent and their radii are congruent. If their radii are congruent, they're congruent circles, right? So if they're congruent circles and they have congruent chords, then the lengths of those arcs are equal. So it's 80 degrees. Because segment FG and segment JK are congruent chords in congruent circles, the corresponding minor arcs FG and JK are congruent. So we're going to get them both being 80 degrees. If the measure of arc AB is 110 degrees, so AB is 110 degrees, what is the measure of arc BC? If AB is 110, what is BC? Anybody? 110. Why? Because they're both in the same circle and both of their chords are equal. If both of the chords are congruent and they're in the same circle, then they're both going to have the same arc measures of 110 degrees. If the measure of arc AC is 150 degrees, what is the measure of arc AB? Anyone? Any idea? So these are equal, therefore these are equal. 360 minus 150. What is 360 minus 150? 210. Divide that in half.
105.
105 degrees each. Three bushes are arranged in a garden as shown. Where should you place a sprinkler so that it's the same distance from each bush? So where should the sprinkler be? Where should the circumcenter be? The circumcenter is equidistant to each what? Each vertex. So this is another circumcenter problem. This is where the perpendicular bisectors meet, right? So the first thing you could do is you could draw the segments connecting these, turning it into a triangle. And then where their perpendicular bisectors meet at the circumcenter, the point of concurrency of the perpendicular bisectors would be equidistant to each vertex. You guys see how this keeps coming back? Remember the perpendicular bisectors meeting at the circumcenter? That's when you had the triangle was inscribed in the circle, right? Like if I took this and I opened it up to one of the points, if it was perfect, it's a little off, then they would all be on the outside, right? Remember this? Because if you took this and turned this into an actual triangle, it should be perfectly inside. I'm off a tiny bit. It's inscribed inside of it. This is your circumcenter. And then that way, from the distance from the point of concurrency from the circumcenter to each vertex is equal. And therefore, the sprinkler, that stream of water, can reach all three of those bushes. Because you know how it goes around, it goes around and it gets, sprays everything. Well, the sprinkler, the radius of the circle is the distance that that sprinkler can cover. And so it's going to hit all three of those bushes. Because they're within its range of water spray, within its spread. Use the diagram of circle E. Let's get rid of this little guy. Use the diagram of circle E to find the length of AC. Tell what theorem you used. So what is this length? Name the theorem. I'm going to describe it. If you have a diameter, if there is a chord that intersects a diameter perpendicularly, if a chord intersects a diameter perpendicularly, then it is bisected. So the length of it should be 14. Which theorem is that? You copied it down today. All right, so it's theorem 10.5, so you're right. Diameter BD is perpendicular to AC, so by theorem 10.5, BD bisects AC. So they're equal, therefore the total length is going to be 14. 7 plus 7 are 14. Find the measure of the indicated arc in the diagram. So once again, we have a chord that is intersecting the diameter perpendicularly. Therefore, it is bisected. So these two must be equal, right? So set this equal to this. Add x to both sides. 10x equals 80. Therefore, x must equal 8. So what do we want to know? We want to know what is the arc CD. Well, if x equals 8, 8 times 9, what is 8 times 9? 72. So here, some people on a quiz or a test might get this one wrong because I bet you would put in your answer column 8 and forget to plug back in to answer the question that they had actually asked. Always be careful to look back. What were they asking? Did I answer the question? You don't want to forget that very last step because that's the difference between an answer being correct or incorrect. So what is the measure of arc DE? Arc DE. So once again, 80 minus 8, 72. This has to be the same as CD. They're equal. How about CE? The whole thing. 72 times 2, right? 144. In the diagram, circle C, we have OR equal to ST, which is equal to 16. These don't say the measure of the arcs, right? There's no little arc symbol. It doesn't say like the measure of the arc. It's not written like this. It's not written like this. So this is actually referring to their lengths, the portion of the circumference, right? No, it's not. I lied. These are referring to, where are they? No, they're referring to the chords. But for some reason, they left out the symbol to tell me. They really should have those little line segments, right? Segment QR equals segment ST, which equals 16. They didn't write this properly. There should have been segment lines on top of them. Okay, so we're just saying that this is 16 and this is 16. Find segment length CU. Okay, so we're looking for this. So, this rule. If you have two equal chords and you have a portion of a radii, right? So it's going from the center, perpendicular to the chord. Then these are equal. Since they're both from the center, perpendicular to the chords, so the distance from the center to equal chords. The distance from the center to equal chords. How do I know it's the distance? Because it's perpendicular. Distance is always perpendicular. So, set these equal and solve. 2x equals 5x minus 9. Subtract 5x from both sides. Negative 3x equals negative 9. Divide by negative 3 on both sides. X equals 3. Plug back in because we're looking for CU. 3 times 2 is 6. Our answer is 6. Do not put 3. The answer is 6. And this one's using theorem 10.6, okay? So since the chords are congruent by theorem 10.6, they're equidistant from C. In the diagram in example 4, suppose ST is 32, CU equals CV, so CU and CV are equal, they're both 12. Find the given length. What is the length of QR? What is the length of segment QR? If these are equal, if the distance from the center to each chord is equal, therefore the chords are equal. 32. just a lot of memorization of rules in this section, in the first two sections. In the diagram in example 4, suppose ST is 32. Okay? And CU and CV are both 12. What is QU?
16.
It is 16. Because this is going to bisect it into 2 equal parts. Good job. What is the radius of circle C? So to find the radius, if we know that this is 16, and we know that this is 12, and we know it's a right triangle, 3 times 4, 4 times 4, 5 times 4. This is a multiple of a 3, 4, 5 triangle. It's a 3, 4, 5 triangle times 4. If you didn't notice that it was a 3, 4, 5 triangle, 16 squared plus 12 squared equals what squared? 256 plus 144 is 400. 400 equals what squared? The square root of 400 is 20, right? 16 squared plus 12 squared equals what squared, or radius squared? 256 plus 144 equals what squared? 400 equals what squared? Square root, square root. 20 equals the radius, okay? So you can always do the math if you don't notice that it's a Pythagorean triple. If you notice that it's a multiple of a 3, 4, 5, you don't have to show the work. It just makes it that much easier. And that was everything on our lesson on 10.3, applying properties of chords. Apply properties of chords. We hope you enjoyed the lesson. Please like our video and subscribe for more videos just like this one. Have a great day.